This is Algebra 2 homework for powers of I. Today is the 18th of September, 2025. Remember that each of these answers is going to be one of four options. Remember that anything I to the power of 0, anything to the power of 0 is going to be 1. I to the power of 2 is, I skipped 1. I to the power of 1 is just I. I to the power of 2 is equal to the, what is that going to be? Negative 1. There it is. I to the power of 3 is going to be negative I. There's a quick way to remember these. There's the long way that we showed in class, but the quicker way is remember that you have 1 up here, positive I up here. It's supposed to be positive I. Negative 1 over here, and negative I. When I have I to the power of 0, there's no rotations, and I'm coming out here to the right. I to the power of 1 is sticking up here, and you get I. I to the power of 2 means you're rotating 1 twice, and then you're getting over here to negative 1, and I to the power of 1, 2, 3 is down here at negative I, and the very famous one, the really nice one, is I to the power of 4, because that is a complete revolution. And we go 1, 2, 3, 4, and you're all the way back here to 1. And this is the key to unlocking all of these problems. We're looking for how many of these I to the power of 4s live in each of these. So here's how you solve number 1. Number 1 is really I to the power of 4 times I to the power of 3. Using those properties of exponents, when I have the same base and I multiply, you add the exponents. I'm trying to get as many of these I to the power of 4s out as possible, because anything that's I to the power of 4 is just 1. Meaning that this is just 1. 1 times I to the power of 3 is simply I to the power of 3, and I to the power of 3, using our chart up here, it's 1, 2, 3 rotations. It's a negative I for our final answer. That's supposed to be a negative I. Negative I. There we go. And then what about number 2? Number 2, again, I'm thinking how many of these I's to the power of 4 can I get out of this? Well, this is I to the power of 4, and then that whole thing to the power of 8. Well, here, let me slow down. It's I to the power of 4 times 8. 8 times 4 is 32. You're starting to think about factors of 32, where 4 is one of the factors. This means it's I to the power of 4 to the power of 8. And this is one of those properties of exponents. When I multiply the powers, that's the same thing as a power to a power. And that means that this is really just, oh, I to the power of 4, I know what you are. You are just 1. So really this problem is 1 to the power of 8, and 1 to the power of 8 is still 1. There's my final answer. Let's try a third one. I to the power of 101. Okay, now this one is not divisible by 4. Luckily, back here, Mr. Sindel gave you one that was divisible by 4. 101 is not divisible by 4, but I know a number that's close to 101 that is divisible by 4. This is I to the power of 100 times I to the power of 1. Notice what I've done. I have first used properties of exponents. When I have multiplication of two bases that are the same, I can add our exponents. 100 plus 1 is indeed 101. But why did I choose 100 here? The answer is because this number is divisible by 4 and close to 101. I know that I to the power of 100 is the same thing as I to the power of 4 times 25, and that's the same thing as, I'm just going to go ahead and write, this is I to the power of 4 to the power of 25, and that's the same thing as 1 to the power of 25, meaning this whole thing goes away, and I'm left with whatever this term is over here, which is just, I don't mean an equal to sign, multiply by I to the power of 1, and I to the power of 1 is just I. Final answer. Again, you're kind of thinking, how can I get really, really close to our number, really close to 101 with a number that is divisible by 4? We'll practice these a lot more tomorrow, don't worry. All right, a huge number, 1,026. So I happen to know a few different things about 1,026. Let me give you some facts. 1,026 is really 1,000 plus 26. Wow, groundbreaking. I know it, but I also know that 1,000 is 250 times 4. And oh, look at that. If it's multiplied by 4, that means that that whole thing is going to be kind of gone. So this is the same thing as I to the power of 1,000 times I to the power of 26. I just told you that down here. I'm using properties of exponents now. And I to the power of 1,000 is just 1. I'm going to go ahead and skip some steps and say that is just 1. Whenever you have this power as a multiple of 4, you just kind of cross it off from here on out. So now I'm really dealing with I to the power of 26, which is much easier, right? And then you're like, okay, well, 26 is not divisible by 4, but I know a number that's under that is. And you can go over it too if you want. I'll show you that maybe on my second method. So I'll do first method and I'll do your second method. First method, let's go under and say, well, this is really I to the power of 24. 24 is divisible by 4 times I to the power of 2. 24 plus 2 adds up to 26, right? And 24 is divisible by 4 because 6 times 4 is 24. Therefore, this entire thing is just 1. And then I'm asked to find what is just I squared. And I can use my little rotation trick. I squared, come back up here. I rotate once, twice, and there's my answer at -1. So come down here and say the answer here is -1. How would you do it a different way, Mr. Sindel? Good question, Mr. Sindel. The answer here is you can go over I to the power of 26. I know that 28 is the same thing. I to the power of 28 is a number, but I went too far. I need to go back down. So I can say, okay, times I to the power of -2. You're allowed to have negatives. We talked about it in class today. And again, just checking, 28 minus 2 adds up to 26. So far, so good. 28 is divisible by 4, so I can use my shortcut and say all of u is 1. And then I need to figure out what is I to the power of -2. And it means there's negative rotations. You go rotation by -90 degrees, -90 degrees, -90 degrees, and you still get backwards to -1, which is still the right answer, -1. Cool, let's try another one. Oh, no, that is the last one. Okay, that's all of them. We have 4 problems. That concludes the homework. Thanks for watching.